Hello everyone. So in this video, let us talk about the AtCoder regular contest 134 problem A. It's not too difficult problem, but I thought to make a video on that because you will learn a lot of things in this problem. So the problem statement goes like this, that Snook bought a bridge of length L. So there's a complete bridge of length L, and he decided to cover the bridge with blue tarps of length W each. You can just assume tarp as, you can assume like some sort of planks that are used to cover the bridge. Now the planks like length is W each. Now below is given the position on the bridge that represent by the distance from left to right on the bridge when a tarp is placed, so that its left end is at the position X, that is from 0 till L minus W. That is, they had placed some planks on the bridges such that the starting position of those planks is X, and obviously it will cover W because the plank length is W, so it will cover the range from X till X plus W, as you can see. Fine. Now the Snook has already placed N of those tarps, so N of those boards, you can assume, are already placed, but there are some gaps obviously in the bridges, so you can assume that there's a complete total length L of the bridge, and there's some W planks, length planks are already installed, N planks are already installed now, and obviously there might be some gaps also in between. Now at least how many more tarps are required, or you can assume boards are required, so that you will complete the entire bridge. That's the whole problem. Now as you can see that W and L are pretty large, so you have to also see that you have to use long here, and N is also 10 to the 5, so you have to do in some sort of a O of N or O of N log N type of approach. Now what you can see here is that the problem statement has an input that we have already placed two boards, that is starting from the index 3 and the you can assume starting from the point 3 and 5, and there's a total bridge of length 10 and each board is of length 3. So let us draw it out to even visualize it more clearly. So 2, 10, 3, let us draw 2, 10, 3, and the points are 3 and 5. Okay, so what you can do is that because it's a bridge complete of length 10, let us draw it out. So as you can see, it starts from the point 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is the complete bridge, as you can assume. Now if I just move this. Now what you can see is that this is L, that is the complete length. This is the plank length. Okay, now there's a plank that starts from 3 and that has a length of 3. So if you just assume that this is 1, 2, 3, this is the complete 3 length. This is one of the planks, and there's a plank that started from length, that the point that is 5, like this point, and it is also length 3. So 1, 2, 3. So obviously the planks can obviously be overlap also, but as you can see now, you can obviously see that this part starting from this to this part, this is empty, there is a gap out there. So, and from this point of time to this point, this is completely filled, this is completely filled, this is completely filled, but this part is also empty. So as you can see that this length is 2 and this length is, as you can see, also 2. So because you have boards of length 3, you can put a board here, one, and one board you can put here, and you will completely fill the board. So I think so 2 is the answer for this, and yes, the answer is 2. So that's the whole problem, how you can do that. Now the most simplest way to solve this problem is just visualize this only. So I'll just remove some part of this drawing and just remove everything. What you can just assume is that let's just take a generalized case. Okay, too far. Yeah, so let us take a generalized case actually. What you can assume is that let's say that there's a complete bridge out there, and what you can also say that, let's say that this is of length L. Okay, there is a plank of length W here, then there's some gap, and there's a plank of length W here, then there's a gap, there's a plank of W here, and there's some gap. You can assume that. You can also assume that there's some overlapping planks also, let's say like this also. So the total will be till this only. You can assume that this is some black, this is some blank, this is some blank, this is some blank, all of that. Now what you can assume, what you are given is this starting point, the starting point for all of those planks. Okay, now what you can see here is that it can happen that there is some gap in the start. So you can assume that there's some 0 point and there's some end point that is L. So from 0 till that particular first point, so the first point from which the particular board is there, there might be some gap here, and also there will be some like smaller gaps in between, and there will be like end gap. So let's say that there's a plank that is here, and then it end till this point of time, and from this point to this point there is some gap also. So you have to just fill all of that. Now how you can do that? Well, first find out this length. So let's say that you have a blank of W length. Now if you have a blank of W length and you have a length of, let's say, you can assume that capital X. Okay. Now how many planks you can fill here? Can you tell me that? What you can assume is that, let's say, just take a number. Let's say that the W is 5 and there is a total X of 7. Now obviously you will be requiring 2 boards here. Why? Because the first board you will fill till 5, and then again for another board is required to fill the last gap out there. So you have to like find out how many like boards are required. So what you have to just find out is finding out actually like capital X divided by W. You have to find out the seal for it. Okay, so you have to find out the seal. Finding out the seal, you can like either use the seal function, or you can also do is that just take like this is just a technique to find out seal also. So what you can do is just take X plus W minus 1 divided by W. This is also one of the way to find out seals. So what you're actually doing is just adding a buffer value, so that if it like even if it is small, you are adding a complete W, not complete like a small version of W, so that it will complete the overall process and like the overall gap, and then you can easily divide it out. What I mean by this is, let's say that like you have you can fill it till 7. Okay, you have total length of 7 and you have a board of size 5. Even if like if the X is 6 also, then also you have a board of length 5, but you have some only one gap is left that you have to fill again. So what you can do is that you have to add the temporary value such that it will over exceed, so that because you have to also add one more board now, because you have to add one more board. So what you can do is that you will add this W 5, and obviously like when you add this 5 it will become like 11. When you divide by and you have to add plus 1. So what you are actually like trying to see is that you are adding a buffer value to this particular point, so that it will completely divide the next value. Okay, so that like you can find out the total number of boards. It's just finding out seal of that particular number. So you can directly find out seal also, nothing to worry about. So now what you can also see is that you have to find out these gaps. So first gap is from the first point to the from 0 till the first point. There's also a gap that is from, so also have to remember that this, if the last point is, let's say, a of n minus 1, then you have to find out difference from a of n minus 1 plus W, because the last point is not this, the last point is this. So this is the gap. So you have to add W also here. So this is the gap, and you have to just find out that, and also the middle gap. So if there's a point, let's say at a of I and a of I like j, then it is not the difference directly between a of I and a minus j. Why? Because from a of I to a minus j, there's also a board of W. So the distance of like between these two boards is this, not a of I minus a of minus j, but a of I plus W is the point, and a of j minus this. So a of j minus a of I plus W is the actual distance between them, and you have to find out the seal of this point with W. And that's the overall logic for this problem. So let's move on to the actual solution for this problem. What you can see is that you have to take the input of n, like the total number of planks you've already installed, L and W, take the input of that, answer is answer. Then take the input of the starting values. Then you have to first find out the number of planks you have to install from the first point till the starting point and the 0th point. So it's actually just starting point, that is a of 0 minus 0. So I've not written 0. So it's that it will tell you or give you the number of planks that you have to install before the first plank that is already installed, and plus W minus 1, which I've already told you, divided by W. It's actually just finding out the seal. Okay, then you have to iterate from, like, because you're taking from 0 till n minus 1, and what you're doing is just finding out the difference, like the actual difference, but from that difference you have to also like subtract a W. Why W? So a of I minus, like a of I plus 1 minus W is the total difference. the total difference is a of j, like a of I plus 1, you can just assume a of I plus 1 plus a of I and this a of I. If you just subtract out this, you will get the complete length, but this also include w also. But you don't have to include that. You have to just include the gap. So you have to also subtract out this w. So subtract out this w. If the difference after subtracting out w become less than 0, which means that they're already touching out or they're already overlapping. So you don't have to do anything. But if there's some difference, you have to just again do the seal and find out the number of boards you have to install. And you have to completely like add an answer. And in the end, you have to just add or see how many boards you have to install in the end. So the last length is L. So L minus the back. So you have told you that you have to find out the length between the last in like the L length minus a of n minus 1 plus w, because this is not the last point. This is the last point, that is a of n minus 1 plus w. So this is the last point and plus the seal point, like seal point divided by 2. So that is the whole thing, and just print out the answer. That is just calculating total number of boards that you have to install. So that's the overall logic for this problem. I hope you understand the logic and the good part for this problem. Thank you.